I'm Mustafa and I'm Senior Hardware and Software Engineering. In this lecture, I will describe some topics in the PCB design with Altium Designer and show you how to create and manage schematic in the PCB library in correct way. At the first, I will describe PCB design processes and then go to the Altium Designer project to show how to create and manage schematic in the PCB library. The main purpose of this lecture is to show how this can be done in correct way. After that, I will describe some useful technicals in Altium Designer and mention that how we can generate a bill of material or a BOM. Finally, I will discuss about how we can source controlling in the project, and I will propose a guide. PCB design. For designing a PCB, at the first we create a schematic and use a schematic library to put the components in the schematic and then place the components in the PCB and then routing the PCB. But designing the PCB is not finished by routing the PCB. The next stage, the Gerber file and the deriv file should be created and sent to the PCB fabrication. And there are many considerations should be taken into the account in the Gerber file and the deriv file creation. After that, the board goes to the assembly to put the components on it. At the first stage, the components should be provided. But which components? The engineer should generate the bill of material and send to the assembly section to buy the components. If the schematic library is created in a correct way, the bill of material or a BOM will be generated automatically. But if the schematic library is not created in the correct manner, the engineer should edit the BOM or bill of material to send to the assembly. So your component provider should contact you many times to correct a possible error or faults. After that, the component should be placed on the board, and depend on the assembly. You should consider some situation into the footprint and in the PCB library. After that, testing. In the testing, there are many testing procedures such as the quality, performance, and the temperature test. And it can be shown that the designing the PCB is not just routing the PCB, and all other parts of the PCB manufacturing and the fabrication. It depends on the designing the PCB and especially in the schematic library. Schematic and the PCB libraries. Each project should have just one schematic and one PCB library. Do not install other libraries and use in the project directly. When you move the project, you should copy those libraries. Don't do that. Just create one schematic and one PCB, and I will describe in the rest. Use unified and integrated library very carefully. Just copy the components from the verified library and check it again with your desired component. For creating of schematic and the PCB libraries can be done in the following. At the first, find the component in the Moser, DGQ, or other famous supplier in your own country. Please do not use one component for all your resistors. For example, if you consider one component in your schematic libraries for the resistors of the 1 kilo ohm and the 1 resistors in the schematic library for 10 ohm resistors. It causes that when you want to create a bill of material, you should manually edit it, and it causes of many bugs. Other advantages of finding a component part number, that you're able to find your board how much it cost. You know, the very important factor for the company is the cost of the board. For example, in company has request to you that designing isolated serial port, and you try to find a component that has a integrated isolated signals and isolated power in one single component, and the price of that component is about $35, but your company needs that the cost of this board will be less than $10. In this way, you are not able to use these components. You should consider the other implementation. For example, using a 4 optical couplers for the signals, and using a DC to DC converter for the power isolated, and after that using a max 232 that is less than $1. So in your schematic library, create a schematic library for each of your resistors, capacitors, inductors, and other components. Then after you copy the component reference, import it into Altium Designer with their parameters, and then create the schematic of component manually and define the pins, or copy from the verify library, for example your previous library or some integrated libraries that are available. After that, attach the PCB footprint. In this stage, be sure that check the PCB footprint. After that, using in the schematic design. At the rest, I will describe these procedures in the Altium Designer project. First, separate your different parts of your design into the smaller parts in the schematic. For example, for the EMC, just use the controller signals. For the power, just power off the microcontroller or others. Now, as you can see in this project, I just have one schematic and the one PCB library. In the schematic library, into the tab schematic library, as you can see, there are many resistor types. For example, 10 kilo ohms, 22 ohms, 0 ohms, and I do not consider one component for all these resistors. You will see why creation schematic library in this way will be helpful to your design and the rest of the PCB manufacturing. Consider that I want to add an 100 kilo ohms SMD resistors. I go to the Mother, I type SMD resistor 100 kilo ohms. Wait it, I can search it in the resistors. I can choose it the brand. For example, I want to use Vishay or Panasonic or Yagao. Thick film resistor. The resistor is 100 kilo ohms, and the size 4.2. Apply the resistor filters. Okay, 9 matches. I will just copy this reference number. This resistor is good for me. The price is high. You can compare the price here. For example, the price is high, so I just use this component into the Altium Designer. In the bottom right, in the panels, we'll search a part search. At that, I copy the part number. You can find it can be found in the Mother. Okay, in this setting you can select your own provider. You can just select, for example, there are DigiKey and the Mother and some other manufacturers enabled by default, but you can choose other provider dependent on your location. Okay, I find it. So I right click and import into the mass pro schematics. Okay, the schematic will be added here. Added. Wishy. Copy what happened. Part search. Click across. Imported. RC. Yes, here was created twice. Deleted. And in here we should change something in the properties. Design it to R question mark. In the comment 1 kilo size. Okay, and double click here and here something else about this. Okay, and that's there. Now we should create a schematic for here. We can copy from other, for example, from here. But after copy and paste it, please try to check it again. That's right. Okay, save it. Just see the pin number 1, designator number 1, number 2, and save it. And in your projects, for example, in the power view, in the library, search 1 kilo. Yes, you can find it here. You can place it here. That's right, very good. But you know that it's our question mark. You don't know what's the next number of the resistors. So how you can find it? You can use the very good tools in the Altium Design, such as known as annotation. Annotate the schematics and just select the power, and you can find that this R plus. Update the changes list, just one change. This means R question mark. This R question mark to R65. Now accept the changes, create and execute and close. After that, you should update your PCB. So go to the design and update the PCB components. and you will find the difference. Now you can see that R65 validate execute. That's right. You will be see the components where. Okay. In the schematic library, you do not have any PCB footprint. So you should add a footprint. Browse from the just our PCB library, just 4.2. Okay, that's right. Copy here. And in the schematic library, just update the schematic sheets. One updated. And then go to the project, save it, and design, update the PCB. You will see that adding the footprint also. Okay, you will notice that. Now, consider that you have this text is very big. How you can you double click on it and can compare the highs, and then here is retail. But consider that you have many designator and you want to change it at a whole. So just click on designator, right click, find a similar object and choose this as the same and apply it. And you can see that in the top layer you can just see that all the designator with these properties was selected. And you can go to the properties and just, for example, 8 millimeters. All of them, going bigger than. But you have many errors about it. Go back. Okay, now I place the resistor R65. Shift S, you can choose just component and other. In L1, you can put it here. You can use the designator. That's right. And in the tool, design or checking, you shouldn't have a problem. Okay. In the DRC, you have one isolated copper here. Consider that in the L2 ground, that it's a very dangerous. You will consider that these pins will not connect to the ground plane, and this ground is float. How you can use it? You can fix it. I think that here will be corrected. I think. You know that you have a very narrow to the other ground plane. So in the test design was testing, you don't have any errors. Okay. And some other topics. For example, you want to see for example, the address bar at the one place in the PCB. In the navigator, you will have all the components, that you can find it. In the PCB filter, the PCB, you can, for example, the EMC address bus here, and click ROS and select all. You can see in L1, you can see that the address bus is highlighted, and you can track it in other layers. You can track it in other layers. So gather the signals that are very important to you, and create a net class, and using the blanket in the tools, place and in the directively in the blanket, and then using a parameter set to put the nets in a class. Other things, please use as much as when you doubt in some design, just use a 0 ohm. The 0 ohm can be really tricky in your design. For example, if you want to know that you do not use a pull down, or you think that if you don't put it here, resistor here, or for example in this buffer you do not know that the BLS0 is always 0, or you can control it with a microcontroller. So I will put a 20 ohm here. The putting a 0 ohm here is very useful if you want to mount it here and wire there. And if you do not want it, just do not mount it. Now, in this way, creating a PCB, creating a PCB, schematic PCB in this way, when you want to create the BOM or bill of material, is very easy. And another important issue about the schematic library, each components have many properties. Consider that in the schematic library here, in the properties, you have many parameters. These parameters are really important, but in every design, in every adding a component to your schematic library, just adding 2 columns. That is the schematic checked or PCB checked. After you check the PCB and schematic, please mention at the value to checked. But how can we use these columns? In here can add dot, for example, checked PCB value not. Consider here, if you put a dot in the front of the check PCB is going to the, but for example you create 100 component in your schematic libraries and you want to manage the parameters at a whole, you can go to the tools and the parameter manager, okay, and find here it's about, consider one, okay, and about our schematic here is not, I just click rust and add and add, and then not, add a column, accept, evaluate and execute it, and you can find that out here. You can delete here this and delete here, yes, and it's about the PCB checked, not checked, and about here not checked, and you can see that which components are not checked, the values are not checked. It's a very good tools to manage your schematic and the PCB libraries. Now I want to generate the bill of material. The boom. In the report, I choose the bill of material. In the left, you can choose the field that you want to print it in the bill of material. At the first, consider that you should select a template. I select the default template 95 and export it to the Excel and to the PCB folder and save it. It takes some time. Okay, I will open the Excel file, and you can see that you have a footprint, comment, library reference, designator, and the creation time and the quantity number. If you send this to your component provider, it now which component should you buy from the Moser or DigiKey. But consider that you don't have a pricing field. How we can add a pricing field or other field that we required here? You should create a column in the template. So in the Altium Designer page, I first copy the BOM default to the projects, PCB, and then open it. Open it here in the Excel, and I just try to add a column, insert the column, and write column call pricing 1. Just exactly the same name in the pricing here, and we shall, and we tick, put a ticket here, and in the here we will be save to PCB, and then try it again, and in the here we choose that, and just in the pricing just export it. Okay. PCB with price. That's it with the price, and you can see that the pricing is here. Okay, now after you creating your project, for example, you want to versioning your versioning. The most common way is to copy your folder and versioning like this, v1.1. But you know that it's not really good. So for source controlling, I will propose using a Git. And in the resting, I will show you how we can send this project to the Git and create a repository there. Now go to the GitLab and create a repository that we can put our code for the first time. Opening the Git server. This is here the local GitLab that I installed in my server PC, but you can just using a gitlab.com to create your projects publicly. I create a new project and the address, for example, my first PCB. Create a process and the IP address. This is the Git. The repository was created. I use the source tree to manage my repository. I just use a clone address. Your Git formation authentication. This is a Git report. Changing the address to PCB and clone. Very well. And you can see at the PCB folder there is a my first PCB. It contains .git. Just copy your controller folder here. But you know that the project is really huge, big because the underlying preview and the history. You can create a .git ignore file and edit it and just put the history and the preview here. This means that these two folders were not coming to the repository. Now I will copy here. Now in the working, you know that there are many files that can be added to the project. You can also ignore, for example, the project outputs or project logs into the git ignore. Edit, for example here, or the project. Copy here. Refresh it. You know that it just remove it. Now the commit. First initialization. Stage all and commit. This is commit on your local folder, but in the master you should push to the server. If you push to the server into the master branch, you will see in the source tree that someone has pushed the code. Now the code was pushed here. You can see it into the source tree, the first initialization, and in your website and your GitLab server, you can see see this file. The files. You can see this file was pushed here. Okay, now open the project. Close the project. Close project. Save none. Open the project. In the PCB, my first PCB here. As you can see here, there are some green line here. For example, consider that in the power PCB, I will delete it here and save it. You know that this will be in the red. That the Altium Designer is supported Git very well. Click right on it, and in the version control, you can commit just this file, commit, remove the resistor, and OK. This will be into the green, that is something commit. But in the source control, you can push one. Okay, the username root, password, test it, transfer on here. Now you can see in the source tree, refresh it, you can see the commit next, remove the resistors. Very good. In this way, you can manage your project very well in the Git. Please encourage me with your valuable comments. Thank you so much.